Hey everybody, how's it going? I am Kuit the Geek. This is Shenzhen I in real life, part 2, the board. Okay, so for just a quick reminder, for this part, what's going to be happening is we're going to go through and lay out our board. So we're going to go through and design a schematic and lay out a PCB using Kicad. So the first thing we're going to do is we're going to jump into a schema. This is our schematic editor. And we're just going to go ahead and start adding parts. So the first thing we need is our Atmega. So that is going to be our processor for this project. The next thing we're going to need is our battery for our power supply. So we're going to just drop in our battery. We're going to need to connect this up to 3.3 volts, so that's going to go right there. And we're going to need to connect the other side to ground. So we're going to just drop that right there. A few things need to go in tandem with this, so let's go ahead and add in the polarized capacitor that we talked about. So that's going to go right here. This is going to actually be a 10 microfarad capacitor, so we'll set that right now. And then we're going to bring in an unpolarized capacitor. This is actually going to be just a generic ceramic capacitor. And this guy is just going to be a small little 0.1 microfarad. So go ahead and connect all of this up right now. Just do this quickly. Okay. So now what we need to do is we're going to grab our 3.3 volts right here, and we're going to bring this up to power our microcontroller. So we're going to just drop that right there and connect that up. Nice and simple. So we're also going to want to add our ground, but we've got this text in the way, so we're just going to go ahead and move this. I always like to bring it up here into one of the corners so that I know where it's supposed to be and I can find it quickly. So we'll drop that there, and now we're going to go ahead and just move our ground into place and connect that up there. Okay, so next we want to add in one more of these capacitors. That's going to actually go to this reference voltage for our analog side of the circuit. We're not actually going to be doing anything with the analog, but this is just part of the reference schematic. We're going to be using the reference schematic for the Arduino Mini, and we're going to be using this chip here, which is the 328PB. Normally the Arduino Mini uses the 328P, and the B is just a different variant. So we're going to go ahead and set that up this way. Next thing we want to do is we are going to get our reset line set up. So what we're going to do with this is we're going to actually add in a resistor here. This is a pull-up resistor, so what this does is it makes sure to pull the voltage high so that the circuit is in a known state. In this case, this bar over reset means that it's active low. So if it goes to a low value or a zero value or ground, then it's actually going to activate this reset. We don't want that to happen, so we're going to put this simple little resistor here to pull the value up to 3.3 volts. And we're just going to set that for 10K. We're also going to put a button, and we're just going to grab this push button right here, and that's just going to be nice and simple, and drop that right in. Or ground and grab a ground. So this will actually give us that grounded out signal if we push the button. What that's going to do is it's just going to drive this whole thing low because it's got a different path to run through, and that's going to reset our processor. So the next portion, we need our crystal or our resonator. So we're going to grab this guy, and we'll just drop it right here. We'll wire this up. Again, this is important because of the timing. It is what's going to help keep everything synchronized so that it runs at the 16 megahertz that we want it to. So we can basically predict what all of our code is going to do on the timing side without having to worry too much. Okay, so next we need to add in a few more resistors. These are going to be for our LEDs. So let's just go ahead and grab this resistor here. I'm going to go ahead and place that here. and we're going to want to move. Well, let's go ahead and set the value for it right now. This is actually going to be 68 ohms. This is what's going to be the value for our 2.1 volt or forward biased LEDs that we're going to be using here. And we're going to just grab 2 of these. We're going to throw them right off of these 2 lines right here. And now we're going to go through our LEDs. So let's go grab the LEDs. We're going to rotate these around, and we're going to put the LEDs right next to each other right here. Draw our traces out, or our wires. That one didn't connect all the way. And now we're just going to grab a ground, and each of these can go to ground. Okay, there we go. So at this point, that's just about it. The only thing we have to do now is take care of our programming header, which we're going to actually come off of these 3 lines right here. These are the lines or the ports that are used for the SPI communication protocol, which is what we're going to use to program this in episode 4. So this uses several signals. The first one is MOSI, which is master out, slave in. This is the convention for SPI. Next one is MISO, which is master in, slave out. And the next one we're going to use is our clock. The last thing we need for labels for our communication, or our programming header, is we're going to need a reset. So we're going to go ahead and tag this onto our reset line. That way, when we do our programming with using another Arduino, we can toggle this reset line and reset the chip. Now, let's go ahead and add a programming header here. Should be the last thing we need to grab, which is going to be this guy. And we'll put this right here. I'm going to go ahead and rename this to prog. And I'm going to rename it program just so we've got the space. Program. Okay. So let's get this moved down here a little bit more. We're going to need to actually have power attached to this programming header. So let's set this up. I'm going to move these so they're far enough away we have space to add in our other lines. Let's get these in here. And keep missing those just by that little bit. Okay, we've got those lines. Now we're going to just come up here. We're going to grab our reset, and we're going to put this, I'm just going to make a copy of it and put it right here on pin 3. And then we're just going to go right down the line where we're going to grab our MOSI, our MISO, and our clock. Okay, so that's pretty much it. That's our schematic. We're going to drop out now and go over to our PCB layout. Okay, so the first thing we're going to want to do here before we do anything else is we're going to want to create our board layout. We're going to shoot for 40 millimeters by 60 millimeters. So we're just going to create this simple box real quick, and then we're going to go through and change all of these values so that we know where everything is and that it perfectly matches our 40 by 60 board outline that we want. Okay, so now we have our board outline. The next thing we want to do is we're going to switch over to our copper layer, and we're going to bring in our netlist. So we're going to read what we just generated here. This includes all of our symbols and all of our footprints that we're going to need for this project. Just going to go ahead and drop this in here. And there's all of our parts. Now we're going to want to start off by placing our battery. We're just going to go ahead and place this in the middle, but we actually want to place this on the bottom side of the board so that we can maximize our space. So we're going to flip it, and we're going to rotate this around. And now we're just going to set our value here to go right in the middle. Now we're going to grab our programming header, which we're going to want to go through, and we're just going to put it somewhere off to the side here. Let's change our grid down so we have a little bit more finite control. Now we want to be careful so that we don't put the programming header in a place where it could cause a problem. So we're going to keep this out of the path of the battery and away from any of the other parts that are more critical. Now we want to move our microcontroller into place. So we're going to take a look around here and see where our pins are for our LEDs. So one of the easier ways to see this, we're going to just drop this right here, and we're going to grab the LEDs, bring them over to the side of the board where they're going to end up. As well, we've got to find the resistors that are attached to them. And you can see already that the rat's nest is showing that this is where that LED is going to be. So let's grab the right chip. Let's see, I'm going to hide that back footprint because it's getting in the way right now. I'm going to grab that, we're going to rotate it around, and now we've got that net closer to us, so that's the orientation we're going to want to have this. Let's grab the other LED, or the other resistor, and all of a sudden I can see that it's crossing over, so we're going to switch these two LEDs to the opposite sides, and that way we don't have to worry about crossing any of our ties. So let's get these rotated around to where they're going to want to be. And we're going to place these in a very specific place here because we want to be able to control where they're at and get that worked out. Okay, so this is going to be 10 millimeters away from this side of the board and 5 millimeters away from this side. I'm going to want to grab this reference designator, and we're just going to move it down here so that it's going to be visible to us still. Now this guy is a little bit different trick because the anchor point for this is actually in the middle of pad 1, and so what we're going to do here instead is we're going to still set this guy for 105, but now we're going to come to here, and instead of being 130, which is 10 up, we're going to set it for 131.8, which is the difference between that center pad and the middle of the part. So I'm going to do the same thing here. I'm going to move this down and place it there. We need to get the resistors right next to the LEDs that they represent. So this guy we can just put right here. I always like to keep these as in line as I can for what we're going to be doing. And that looks like it's just a little bit off, so we'll see if we can shift that over, and that should be good. So I do want to go through and center this guy just like we did with the battery. So let's go through and do that now. And while we're here, we can go ahead and run the traces for our LEDs. That'll work. Doesn't have to be anything fancy, it just has to be functional. So we've still got a few more parts that are over here. Let's go ahead and next we're going to grab our resonator. So that will get us our resonator in place. We've got a few other capacitors and things still. So let's go ahead and we're going to grab this capacitor. This should be for our analog signal. So let's move the reference designator down here and scooch this guy up right to here. And we can just go ahead and run these traces. We're going to run that one to ground specifically just so that we can make sure it's connected. Because we are going to go through and add a copper pour here in a minute, but we are going to wait on that one for right now, and that can cause an issue where it just won't have that connection made, and we want to verify for sure that that is connected. We also need to connect our 3.3 input lines. There's two of them on this particular part, so we need to make sure they're both connected. And we've got our input capacitance left, as well as our pull-up resistor and our switch. So we're going to grab our bigger input capacitor here, and we're just going to bring this guy right here as close as we can, again with leaving some distance between so that we can have a port that's going to go from this ground out. We might still have to do some stuff to add in that port, or to add in that connection, but if that's the case, then we can do that real fast. So let's move these guys out of the way so that these two capacitors can sit right next to each other, and we'll just kind of nestle them right up together, and we're going to connect this guy. The last thing we've got is our switch and our resistor. So this switch we're going to go ahead and just put right about here. Alright, that looks good. So now we've got all of our parts placed. Let's go ahead and turn our back footprint back on so we can see that. The next step that we want to go through and do is we're going to add in a ground pour so that all of our grounds are going to be connected to the same place, and a lot of these rat's nests that you can see are going to get cleared up just by having a plane that it's going to get connected to. Okay, so next we're going to jump back down here to the ground, or to the bottom layer, and we are going to actually connect these two pads together. They are pretty simple. They are the same value, same reference pad, so they don't know any better. They just know they're supposed to be connected, even though they will be connected with metal that will come across here. The board itself doesn't quite understand that. And then we're just going to drive this guy out to here and make that connection. Let's come back up. There's only a few more that we really need to make, so let's get that done quickly. And let's go ahead and grab, first of all, our resistor here, and get that tied up to the ground, or to the 3.3 that's right below it. And then we've got this 3.3 that needs to get tied down, so we're gonna just go ahead and drop that onto here, and that will give us power to the chip. Now we are having this little issue here where this ground is not connected. If we jump over here and look at the filled view, you can now see that all of the traces are in here, but there is not enough copper to actually bring it up to connect in. So we're just going to solve that by running a trace ourselves right up into this copper pour. Now we have a ground connection. So we'll just turn that back off. We've got the 3 lines for our programming header that still need to be done. So let's do this. We're going to start actually on the bottom side, and we're going to wrap down and around here, and we're going to pop up over here with our via and connect in. The reason for this is because we actually have to go through and jump each of these lines. So we're just going to carefully route this around, and we'll just drop our via right here, and then you can see we're dropping another one. Oop, that's going to interfere, so let's see if we can drag this from the other way and try to clean this up a little more. There we go. I always like to try to keep my traces at 45 degrees and something that looks clean and tidy. So I'm not really being as particular as I would be. just because it's not as necessary for this project, but it's just something simple and giving proof of concept here. So we're just gonna wrap this guy like that. I don't really want to leave that as exposed as that is, so let's bring this elbow in here and we'll bring that guy up with those. Go ahead and fill, and at this point everything should be connected up. So we're going to go ahead and save, and we're going to run our DRC, this is our design rule check, to make sure we don't have any problems, make sure everything's connected, everything's refilled, no problems, no one connected, all good to go. So at this point, let's take a look at the 3D representation of what our board's going to look like. So you can see we've got the LEDs that are going to be coming off the side of the board, got the battery underneath, and we've got our programming header. Now there's a few things that we're still missing. First of all, we don't have a name on this board, so we couldn't tell it apart. So let's go ahead and add that. So we're going to come to our back silkscreen. We're going to add some text and make sure that's mirrored. And this is our big security camera. And this is going to be Rev 1.0. We're just going to drop that up here in the top corner. And then, of course, we need to make sure we have our personal brand on it. So we're going to come in here to our footprints, and we're going to add our logo. So this would be on the front side. Let's go ahead and flip this, rotate it around. So we'll leave it there. That's okay. And that's pretty much it. That's our board done. We don't need to do anything else. It's ready to go. The only thing we have to do is create some manufacturing files. So we're going to go ahead and plot this. So we're going to go to our Gerber folder that we've created. We're going to plot our front copper, our back copper, front silkscreen, back silkscreen, front mask, back mask, and edge cuts for this particular project. And we're just going to hit plot there, and we're going to generate our drill files, going to the same place, and generate a map file. That's not really necessary, but it can be helpful for some fabrication houses. So that's our Gerber files, so that's the file format we'll use to actually send this off and get it made. Let's go ahead, and we're actually going to now kick out a step file. And what this is it's a mechanical file that has our 3D representation of a board. We're going to use this in the next episode when we actually go through and design the housing. But for right now, let's just go ahead and generate this. We're going to ignore that for now. And we'll go ahead and close that out. And that's our board done. So we're going to go ahead and send off for this. And we should have it in a little bit. And we can revisit this in episode 5 when we actually go through and build everything. Alright, that's pretty much it. So we've got our schematic done. We've got our board laid out. At this point, the only thing I have left to do is order the board and have it sent out to us. I'm going to be using a service called PCBWay out of China. They're probably the cheapest that I've seen for PCB fabrication. So that's what I'm going to be going with. As far as it goes, when the board does get here, we'll be able to go through and build it up. That's something to be looking forward to for part 5 when we actually do the final build. So for right now, that should pretty much have us set up for the next episode. So keep an eye out, and I'll be dropping that next episode in just a little bit here. In episode 3, just a reminder, we're going to be going over the box. So we're actually going to design the mechanical side of everything and get that done. All right, everybody, thanks for joining me, and we'll see you in the next one. As always, make sure to like if you liked this video, leave a dislike if you didn't. Let me know in the comments what I could do better or what you did like about it so I can keep improving. Thanks for coming, and we'll see you in the next one.